So let's say this is 30 degrees. What is this angle in terms of radian? How much?
Pi over 6.
So pi is 180. So 1 pi radians is equivalent to 180 degrees. This is the scale which you are going to use. Okay. Let's say 120 degrees. This is
4 pi over 6. Or 2 pi over 3.
2 by 1. Okay. Let us understand some concepts of trigonometry. So let us first understand about standard position. Standard position means if there is a terminal arm like this, an initial arm like this, this is said to be in standard form. Basically, it should lie at origin, start from origin. Second thing is initial arm. This red arm should point positive x-axis or horizontal direction. So two things to keep in mind. So an angle is said to be in standard position when these two conditions are met. So let us understand in detail. So let's say the coordinates of this point is, let's say 1, 1, and it is said to be in the standard position. What is the value of theta? So the question in standard form, coordinates of point P is given. Angle with horizontal positive x-axis is theta. How much is theta?
Like what the angle is?
Yes.
How would you find that?
Well, in standard position means this point is at origin, right?
Yeah.
So it's like this. This angle is theta. So 1, 1 means what? X and y coordinates, right?
Yeah.
So this horizontal distance is 1. Vertical distance is 1. Also 1. So use trigonometry basically.
Oh, okay. Yeah.
Can you tell me directly what will be the value of theta?
You would have to do like side of theta equal, or no, you'd have to do like tangent, right?
Tan is equal to?
So then just one. So then
So for 1, theta is how much? Tan theta 1 means what is the angle?
wait. Is it like a known one, or does this have to be put to a calculator?
Well, I mean you can do it either way, but we know this value actually.
Oh, yeah, it's 45.
45. Or in terms of radians it is?
Pi over 4.
Pi over 4. Okay. So that is the way. Or alternative way to look at it is, this is 1 isosceles triangle. This will be 90 degrees, right?
Yeah. So then the other two have to be 45.
So right isosceles that is. So next thing is, let us generalize the concept. Let's say in standard position, it means this is called terminal arm. This is initial arm, and this angle from initial to terminal arm is called principal angle. Okay, let's say the coordinates of P is x comma y.
So of so then to find like the angle, you have to do like Pythagoras. Wait, everyone.
Yeah, let's say the length of this terminal arm is r. We usually represent it as r. We know that in this
Yeah.
triangle it is the hypotenuse, the longest side. Correct?
Yeah.
R is equal to length of terminal arm, or we know that it is the hypotenuse. Okay, so in that triangle, if you study the triangle carefully, this angle is theta, this is 90 degrees, this is r. How much is this length?
X,
The other one is,
Y.
so first things first. Application one is Pythagoras theorem, which is
R, yeah, squared equals X squared plus Y squared.
this is the first application. Second thing which is important is how much is the sine theta in this triangle?
Y over R.
So sine theta is y over r. Cos theta is
X over R.
x over r. So when we talk about the coordinates, it is x and y. Coordinates of that point. Let's say this is point P. So x and y are important. So there is formulas. Y is equal to r sine theta. X is equal to r cos theta. So these are important to remember. So this is this is number 3. So few things to keep in mind is note x and y are coordinates of the point. Coordinates of point on the terminal arm. What is r here and what is theta here?
R is like the length of the
Hmm.
terminal side, and then that's the angle.
Length of terminal side or arm. Theta is principal angle. We measure it with positive x-axis, not anything else. So any coordinate in the plane, xy plane, Cartesian plane, can be found using this formula. X is equal to r cos theta, y is equal to r sin theta.
That's defined just like the side length, right?
Well, x and y are what? Coordinates, correct?
Yeah.
Yeah. So any coordinate in a plane, let's say if you choose a random point in a plane, let's say here, 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 doesn't matter. That can be found using this formula. X coordinate will be r cos theta, y coordinate will be r sin theta. Theta is, let's say I mark these points A, B, C, D. Let's talk about B for now. B means you have to join this with the origin to set it up in the standard position. So place it in, start from the origin, draw towards that. So this length is r, right?
Yeah.
So if this angle is theta, coordinates of B will be r cos theta, comma r sin theta. Direct. Okay. Scroll down. Okay, let's go to the next page. So remember that formula, r cos theta, comma r sin theta. So let's say the terminal of arm is something like this, and this angle is, let's say, pi by 3. In this length, it's a 1 unit. This is point A, coordinates of point A. Try to find it.
So it would be the x is r sine or cosine?
X means cos.
Okay, so then it would be cosine pi over 3, which is equal to cosine 60, which is that 1/2?
So R is 1, right?
Yeah.
So the answer is 1/2. However, this is incorrect. Can you guess why?
It would be minus 1/2 because it's in the second.
It's in the second quadrant.
What?
So we need to watch out for signs if you follow this method. See, what did I tell you? R cos theta, right?
Yeah.
See, theta is not this angle. What is theta actually?
Like the angle from the positive x-axis.
Here to here, right? This is theta. So basically theta here is not pi by 3, but how much?
120. So 2 pi over 3.
Pi minus pi by 3 or 2 pi by 3 or 120 degrees. So cos of 2 pi by 3. I mean, now you can use the calculator. Look, it is, so r cos theta is equal to 1 times of cos 2 pi by 3. So if you put 120 degrees, it will be minus 1/2. So here we're directly getting the answer minus 1/2. We don't need to watch out for signs. So that is why this formula is important. The trigonometry part, cos or sine theta for x and y, will take care of the sign of the coordinates, whether it is positive. What happened?
Because I'm just saying, like, it takes care of the sign.
Yeah, the trigonometry part takes care of the sign. So cos theta, theta means with respect to positive x-axis. So that I have written that point in the note section in the previous page. So no need to worry about that. Angle with plus x. So these are some points which are important to remember. I mean, if you understand this, we can skip a lot of topics because basically they are the different version of the same concept. Angle should be measured with respect to positive x-axis. Okay, what about tan theta? How much is the tan theta? Let's say I consider the same concept. Let's say x,
like
comma y.
In terms of x and y.
Yeah.
It's gonna be y over x.
Y over x. Trigonometry part will take care of positive or negative signs.
Yeah.
Yeah, yes. And in trigonometry, like what did they cover in algebra 2? So this is the question. You're on page 5, right?
Yeah. So the period would be 8.
Yeah, so period would be
And then,
7.4.
yeah. And then for when it's between 92 and 95, so you have to find for like what the value will be when it's like 92, and then the value for when it's gonna be 95, right?
Yeah. So graph will be repeating, right? So on at 92 and 95. What is the nature of graph? Is it increasing, decreasing, like that? You have to comment.
So when the graph is at 92, it'll be at 0, and then when it's at 95, the graph will be concave up, but it'll be decreasing.
Okay. What is this 0? How do you know it is 0?
Yeah. Because like if it were to continue, it lines up with like.
Okay, let's say 93. What is happening now? This is 93.
So if it's 93, then it'll be like more below. Like it'll be below the x-axis.
So the function is increasing or decreasing. Two things. See, two things. Increasing, decreasing, concavity up or down. Common nature of function means. Okay?
Yeah.
So it is increasing or decreasing. First things first. Tell me.
Decreasing.
Two things.
Decreasing.
Okay, yeah, decreasing. And concavity?
Concave up.
Up. Okay. So the interval is given 93 to 95. We know that it is the same as if you subtract the period. What is the closest multiple of
What?
period? What happened?
Sorry, you cut out for a second. What did you say?
Oh. Is it clear now? Like the voice and
Yeah.
all? Okay. So basically the interval is given 93 to 95. So if you subtract the period to this interval, it behaves the same. So 93 to 95, nature at this interval is same as, what is the closest here? Closest multiple of 8.
Like 88.
88. So if you subtract 93 minus 88, 95 minus 88. So basically this is so same as
5 and then
93 to 95 minus plus 2, right? So 5 to 7. So 5 to 7. So in this original question, 5 is something. Where is 5 actually?
like it's slightly after the 4, so you can see that it's like below the x-axis.
Okay, I'm drawing it here. So 4 is here, 8 is here. Okay. So 5 will be here, 7 will be here. So basically, we have to split the function like this, because in the middle it is 6, right? X is equal to 6.
Yeah.
So here to here it is decreasing. 5 to 6 it is decreasing, and 6 to 7 it is increasing. So that's what. So we have to split. So when we talk about 5 to 7, we say that for 5 to 7, 5 to 6 decreasing, for 6 to 7 increasing, and overall it is concavity how?
Up.
Concave up. So up means U shape. So it is U shape. Simple, right? So the nature of function means two things, whether it is increasing, decreasing, and concavity. That's it. Only two things.
Wait, to find the area?
Coordinates of points A, B, C, D, vertices.
Okay. So we would have to draw like a line from the origin to each of the coordinate points, and then we would do like r cosine of the angle, and then like r
What is,
sine of the angle.
yes, what is R in this case?
It would be like the length from the origin to A, or like to the coordinate points, but we don't know that, do we?
We don't know that. But what is the given data? Like, try to interpret the data. What is given already?
So can we keep it in terms of like x and y?
See, square side length is given, right?
Oh, where? Oh, 4 centimeters, yeah. So we know that. But so can we assume that from A to the origin is 2? Like it's an even split? Like
Well, the thing
the
is,
line from,
see,
yeah.
side lengths are 2, okay?
Okay. Okay, so
Okay, let me just increase this. See, how much is the angle at B?
Right now it's at 90.
90 degrees, of course. If you look here,
So if you were to draw a diagonal through it, would it become 45?
yeah.
Okay, so then if you were to draw both the diagonals,
See, let us
and
understand
that
this.
divide, yeah.
See, these 2 points are on the circle, right? If you join these diagonal points, we don't know if it is passing through origin or if it is something like this. If you join these 2 points, the thing is, if you join these 2 points, this angle is 90 degrees. That means AC is the
You have an isosceles triangle?
circle theorems. AC is the diameter if this angle is 90 degrees.
Oh, yeah.
AC is diameter. See, we don't know if the diagram, initially we don't know if the diagram, if you join with the origin, will it be something like this and this. Right? We don't know if it is symmetric throughout. Let's say this is something like this. Another angle may not be something like this. It will be like this. So to understand that, AC is the diameter because angle B is 90 degrees. Diameter of circle. So origin, we know that center lies at origin of circle. Center of circle is at origin. So basically OA is equal to OC radius. Any doubt?
No.
Okay. This R is important, right? Like to find the length of the R, that is important. To find the coordinates of A, B, C, D. So how do you find length R?
So we know that the side lengths of like BA and BC are both 2. And we know that angle B is 90 degrees. So we have an isosceles triangle. So then if the angle is 90 degrees, the other two have to be 45. So then the total length of AC is going to be 2 root 2. And then since we know that OA is equal to OC, we can divide that by 2, and then we just get root 2. So OA is root 2, and then OC is root 2, and that's R.
Okay, side root 2, right? I mean, side length is 4 centimeters. AC is 4 root 2. So OA, so R will be how much?
2 root 2.
So now can you find ABCD coordinates?
Yeah. So then A is going to be X is equal to sine, or R sine of theta, right?
X means cos. X means cos.
Oh, yeah.
Okay.
So then to find the X value of A, it's going to be, but we don't know the angle of theta, right? Or can we assume?
Like what is that shape called? ABCD.
A square.
A square.
Oh, so we can assume that it's 45.
The diagonals of a square bisect the angle at the vertex, correct? So basically, if this is 90 degrees, the red diagonal here bisect this angle.
It becomes 45 and 45.
So this is also vertically, alternate interior angles. This is also 40. Okay.
Yeah. So then it's going to be 2 root 2 multiplied by cosine of 45. So 2 root 2 times root 2 over 2. Yeah, root 2 over 2 times 2 root 2.
Yes.
So then
2 right?
Yeah, and then the y is going to be 2 root 2 times sine of 45.
That is also equivalent to 2.
Yeah, and then for coordinate point B, it's going to be 2 root 2 times minus, well, we know that it's going to be minus, so can I put it before?
Yeah, because it is a square, we can directly comment on the coordinates. If this is 2, 2, like this.
Minus 2 root 2, and then C is going to be minus 2 minus 2, and then D will be positive 2 comma minus 2.
Okay, so coordinates is fine. Okay, can you tell me the theta for angle B? How much it will be? Theta.
Like from the
Principal angle.
side, yeah, it'll be 135.
So we have to write here cos 135. So 2 root 2 sine 135 for my coordinate. So we know that 135 means second quadrant. Sine will be positive. Answer will be positive. Cos will be negative.
Negative.
Trigonometry will adjust to that. So that is what. Can you tell me theta for angles? Point C.
For point C, from the original, it's going to be 180 plus 45, so 225.
So I'm writing here theta C is 225. Theta D is
270, or no, it's 225 plus, or 360 minus 45.
or
So 315.
yeah, or 270 plus 45.
Yeah.
270 plus 45 is equal to theta D, or 360 minus 45. Or sometimes we can also say it is minus 45 degrees.
Yeah.
Clockwise angle is negative. Clockwise measurements is negative. Counterclockwise angles are positive. So that's it. So let's move on to the next page. When unit circle, I think you know already. This is what do we consider?
Because
Yes.
like for when you find the exact values, it's like simplified.
Yeah. One other explanation is, let's say if there are a bunch of triangles like this. How many triangles do you see here?
Wait, or did you move on to the next page?
Yes, page number 7.
Yeah, I see it now.
How many triangles are there here? Right triangles?
1, 2, 3, 4.
Just 3, right?
Yeah.
So basically, this, this. What do they all have in common?
The 90-degree angle.
Is that all?
They have the same angle, like over here, angle A.
Yes. So another angle is angle A. So A criteria says that triangles are,
Similar.
all of these triangles are similar. Like this, this. So basically, similar triangles means ratio of corresponding sides is same. Corresponding sides will be equal. So if you take any pair, let's say BC, let's say BC by AB, this by this should be equal to this by this should be equal to this by this. So we know that, let's say if it is theta, this by this is called
Like in terms of theta, it'll be sine.
Yes. So sine theta. So for this triangle, this is called sine theta. Like BC by AB. So for the larger triangle also, opposite by hypotenuse,
Yeah. So DE over AD.
D over AD. So that is also equal to sine theta. So regardless,
Sine theta. Yeah.
so
Will be the same no matter for any triangle.
yes. So basically, ratio of it is not just for sine, but for cosine and tangent, secant, cosecant, will be the same. So regardless of the size, so even if you take 30 degrees like this, even if you take 30 degrees like this, if you take the ratio, sine theta will be constant. Sine theta will be same. So yeah, that is why when you talk about unit circle, the radius is 1. 1 is a bit convenient. That is why we consider unit circle. We solve it at this small level, not some big number like 2, 3, like that. That is the reason why we consider the unit circle, because the results obtained for unit circle will be the same as any other triangle, any other radius. So for simplicity, we use unit circle. Okay. So now that we understood that the results for unit circle is going to be the same for any type of circle, will be the same as any circle radius. So this is, let's say 1. Let's say this is theta. Coordinates of x is x coordinate of, let's say, point.
Yeah. So you know what r is, so then it would be cosine theta and then sine theta.
Sine theta. Simple. So let's say this time is a bit reverse. The coordinates are given. Let's say 1 by 2 comma. Let's say root 3 by 2. Find the principal angle. This is the question.
So you would have to find the r value by just plugging it into like the equation. So r equals r squared is equal to x squared plus y squared. So then 1/2 squared plus root 3 over 2 squared, and then the root of that. So then it would be 1/4 plus 3 over 4. So then that's 1. So then r is just equal to 1. And then once you have that, you can then find, like, plug in to the other equation. So 1/2 is equal to cosine of theta, and then you do r cosine.
So theta will be,
R cosine of 1/2.
yeah, r cos 1/2. Yes, how much?
So then, yeah.
1/2 means,
Like, huh?
half means how much angle it is. Cos theta half means.
Oh, it's 60 degrees.
Okay. 60 degrees. So from here we have found that. Do we need to do for y also? No need, right?
No.
R cos theta. One formula is enough. We don't need to again plug it for root 3 by 2 is equal to r sin theta. No need to do all this. We have found the answer already. So yeah. So that is about principal angles. Let us do one more question. And obviously, in this question, it is in standard position. Standard position means from starting from the origin, and then initial arm is pointing towards positive x-axis. See, angle means something like this, right? Combination of two
Yeah.
A's. So if this is the main player, if we call this is the terminal one, can we say that it is the initial one?
Yeah.
So basically, standard position means this initial arm should point towards positive x. And angle measured will be initial to terminal like this. So that is the principal angle in standard position theta. And in trigonometry, did they teach you like, okay, so to find the trigonometry values of larger angles, we follow the first method as observe the angle, it is 500 degrees, find the closest multiple of 90 degrees. So 450 or 540. Let us take 540. So 500 can be written as, in terms of 540, how?
500 plus 40. Or 500 minus 540 minus 40.
540 minus 40, right? You have to write it in terms of multiples of 90. So it's the same as, see, what is this multiple? Is it an even multiple or odd multiple of 90 degrees?
Even multiple.
So 540 is even multiple of 90 degrees. So that means in the answer, there are two things to take care. Okay. We'll talk about that. Since it is even multiple, that means sine will remain as sine only. Sine of 40. My bus.
Yeah. So if it were odd, would it go to cosine?
Yeah, if it is an odd multiple, let's say 450, we can write 450 plus
90
50 degrees.
or 50, yeah.
So sine flips to cos, okay?
So it would be cosine of 50.
Okay, not yet. See, first things first, we have understood how the trigonometry plays the answer. Sine or cos. So if it is even multiple, it does not flip, sine remains the sine. If it is odd multiple, sine flips to cos. This is the first thing. There is one more thing to take care. Which is positive or negative sign. What will be the answer? Whether it will be positive here or negative here. So to find that, it's a bit straightforward. 500 will lie in what quadrant?
In the third quadrant
Okay.
or fourth quadrant.
Hmm.
Yeah. Isn't it in the fourth quadrant?
Well, it depends on the case. Let's say, yeah, 450 plus 50, right? So you are writing in terms of
540.
we are talking about second case.
Oh, okay. So in the second case, 450 will be like just 450.
5 folds of 90, right?
Yeah.
1, 2, 3, 4, and then 5. So it will lie at
Yeah.
here. 450 lies at here. So 450 plus 50 means it lies in this quadrant. In Q2, sine is positive or negative?
Sine is positive.
So it will be, answer will be positive. So write it as it is. 50 degrees. Okay. So drop it as it is. Here it will be 50 degrees. And in this previous case, since we know that it will be positive, 500 lies in Q2. Answer opens up with positive sign.
Does it? Yeah.
Sine of 40 degrees. That's it. We don't care about this negative or positive. Directly drop it as it is, 40 degrees. Okay.
Yeah.
So let's say sine of 310 degrees. Or let's say tan of 310 degrees. Try to find this.
So we take the closest multiple of 90, so that would be 270. So you can rewrite it as tangent of 270 plus 40.
40.
So then you need to find where it is on the graph. So it's going to be in the fourth quadrant.
Yes.
So that means the sign is negative.
310 is Q4. In Q4, tan is negative. So the answer opens up with negative.
This one you'll take cosine.
See.
So negative cosine, yeah.
270 is even or odd multiple of 90?
Odd.
Odd multiple. So tan changes to cot. Okay. Tan flips to cot. Sine to cos, cos to sine, tan to cot, cot to tan. So cot of, put the angle 40 degrees. Okay.
Yeah.
So this is the answer. So this is how you reduce higher angles into this. So two things to keep in mind. One is the answer opens up with positive or not, positive or negative. Second thing is, will the trigonometry ratio flips? Sine to cos, cos to sine, or tan to cot. So to deal with larger angles, I am write it here. So first we write the angle in terms of multiples of 90, correct?
Yeah.
Second thing is, notice if it is even multiple or odd multiple of 90. Second step is two things to keep in mind. The answer is opens up either with positive or negative sign. Another one is, will the trigonometry ratio flip? Sine to cos, cos to sine, like that. So these two answers you need to answer. Sine to cos, cos to sine, tan to cot, like that. And similarly cot to tan. Cot. C means cot, not cos. So that's it. So how do you determine will the ratio flip or not?
Based on whether like the multiple is odd or even.
So for even, what happens?
For even, it stays the same, but if it's odd, then it switches.
Yes. For even multiple, stays the same. Ratio, trig value stays the same. For odd, it flips like this. And how do you determine whether the answer opens up with positive or negative?
That's based on like where it is on the graph.
So we need to know quadrants. Quadrant of the angle. So whether in which quadrant does the angle lie? And we use ASTC. Right? ASTC. To determine whether the answer should open up with positive or negative. Okay.
Yeah.
Okay, let's say there is this question, sine of 90 pi by 7. Try reduce this angle. 90 over 7 times pi, right?
Yeah.
So convert that into degrees first. Simplicity. Into 180 by pi, right?
Yeah.
So 90 by 7. So 90 by 7 times 180 by pi. So pi, and then you divide by 7. How much is it total?
Uh, it's saying 2,314.285 or 286.
Okay, 0.2 degrees. So 2340 degrees means it lies in what quadrant? See, the simple way is we are writing this answer as some 90 into
Oh, wait.
something plus remainder, right?
Yeah.
So basically you divide the answer by 90. Okay.
So it would be in the fourth quadrant.
Okay. Well, how? How
Well,
much?
when you divide, yeah,
How much is this angle? If you divide by 90,
you get 25.7.
okay. So that means the angle is same as 25.7 into 90 degrees, or 25 times 90 plus remainder is
2314.
2314.2. Dividend is equal to divisor into quotient plus remainder. How much is the remainder?
0.7.
0.7. Remainder. Like, can you convert that into fraction?
Oh, yeah.
Okay, we can do it like this, right? 25 nines means 225. So 2250.
Yeah.
So 2250 plus what?
It would be 6, huh?
2314.2. 2250. Subtract that.
Yeah. So,
64.2. Okay.
yeah.
So 2250 plus 64.2 degrees. That is the angle. So sine of 2314.2 means sine of 90 times 25, which is odd, correct?
Mm-hmm.
Plus 64.2. So can you tell me the answer directly now?
Like for which quadrant it's in?
Yeah. First things first. In what quadrant it is in?
Quadrant. Uh, so it's like, wouldn't it be in quadrant 4?
Okay, we can look it like this. 90 times 1 times 2, 3, 4.
Oh, wait, no, it's in the second quadrant.
It's in the second quadrant.
Yeah.
Yeah. So this is, say for full rotation, 4 multiples of 90.
Yeah.
So 25 means
So,
up to 24, it will be here. Up to 24, it will be here. And then one extra 90 means it will be here.
and then you add, yeah. And then you add 60.
Hmm. Yeah. So it is in Q2, right?
Yeah.
So Q2 means sign is positive or negative.
The sign is positive.
So plus, will the sign, what next?
So now that you know it's positive, now you look at the multiple to see whether it's an even or odd. And it's an odd multiple. So that means you change the sine to cosine.
Drop it as it is. Okay, this angle.
Yeah.
So this heavy angle can be reduced like this. I mean, they don't ask this much of tough questions.